Hello everyone, I welcome you all to this channel. Today's video is on how to count the number of triangles during exam or in competitive exams without spending so much time on counting the number of triangles. In this first slide, there are four figures: number 1, number 2, number 3, number 4. So in the first figure, it is a simple triangle. So without spending much time or without thinking, we can tell there is one triangle here. And in the figure number 2, the figure is still simple, so we can still count the number of triangle. This is the first one. This is the second triangle. And this is the third triangle. So by counting, we can say that there are three triangles in figure number 2. But if we know the formula, we need not count like this. We can tell the number of triangles that are there in this figure number 2. So the formula is we have to count the base of the triangle. So here is the base of triangle. This is the base of triangle. So we have to count how many bases are there. So this is the 1 and this is 2. So the number of triangles will be number of triangles is equal to 1 plus 2, that is 3. So there are 3 triangles in the figure number 2. And come to figure number 3. Same, we have to count the base 1, 2, 3. So the number of triangles equal to 1 plus 2 plus 3, which is equal to 6. So in this figure number 3, there are 6 triangles. And now come to figure number 4. Here also we have to do same thing. Count the base 1, 2, 3, 4, 5. So number of triangles equal to 1 plus 2 plus 3 plus 4 plus 5, which is equal to 15. So in the figure number 4, we have 15 numbers of triangles. And now suppose there is in the exam, the figure might also come that the triangle have like 10, 20 bases. So how we will count? In that case, it is very difficult to add this number of base. So we have to use one formula. The formula is n multiplied by n plus 1 divided by 2. So we have to use this formula, where n is the number of the last base, or the number which is correspond to the last base of the triangle. So let's take this figure number 4. So the n will be corresponds to 5 plus 1 divided by 2, which is equal to 5 multiply 5 plus 1 6 divided by 2, which is equal to 5 multiplied by 6 30 divided by 2 equal to 15. So in the figure number 4, 15 triangles are there in this figure number 4. Now this is another figure which we see here. It's a little bit it's more complicated than the previous figures. So here also what we have to do the same. Count the base of the triangles. This is 1, 2, 3, 4, 5. And for this triangle also we have to count the base 1, 2. And for this triangle also we have to count the base 1, 2. So now the number of triangles for these triangles will be 1 plus 2 equal to 3. And the number of triangles for this small triangle 1 plus 2 equal to 3. And the number of triangles for this big triangle, we have 1 plus 2 plus 3 plus 4 plus 5, which is equal to 15. So 15 plus 3 18, 18 plus 3 equal to 21. So the number of triangle in this figure is 21. In exam we might also get a figure like this, where we have to count the number of triangles. So here also we have to use same formula. We have to count the base. So here this is the, or we count the big triangle. This is the first triangle. We have to count the base of this 1, 2. And now we have to count the base for this triangle. For this triangle, this one also 1, 2. And then we'll count the triangle for this one. This one also there is two base. There are two base, 1 and 2. So the triangle for the number of triangle for this bigger triangle, we have 1 plus 2 equal to 3. And then the number of triangle for this middle triangle, 1 plus 2 equal to 3. And then the number of triangle for this small triangle, we have 1 and 1 plus 2 equal to 3. So the total number of triangle in this figure, we have 3 plus 3, 6 plus 3 equal to 9. So the number of triangles in this figure, we have 9 triangles. In this slide, we have 3 figures, 1, 2, and 3. So we have to count how many triangles are there in this figure. In this figure number 1, we can count like 1 and this triangle. So in this figure number 1, we have 2 triangles. And in figure number 2, also we can still count. This is 1 triangle. This is the second triangle. And this is the third triangle. So we find in this figure number 2, we have 3 triangles. And then in figure number 3, if we have to count same thing like we count for figure number 1 and figure number 2, we will take so much time. So what is the formula here? The formula here is we have to count the number of horizontal lines. So we have to count the number of horizontal lines. So this is the first one, 1. This is second, third, fourth, fifth, and this is the sixth horizontal line. So that is the trick of counting the number of triangles in case the figure is like this. So we have to count the number of horizontal line. So the total number of horizontal line is equal to the number of triangles. So in the figure number 3, we have the number of triangles equal to 6. So our trick is number of horizontal line equal to number of triangles. This is the trick of counting the number of triangles in this type of figure. In this slide, we have 3 figures, number 1, 2, 3. And in all these 3 figures, they are like of same pattern. So in the exam, if this type of figure came, so we have to know one formula how to count the number of triangle by using this formula. Formula is n multiplied by m, n plus 1 divided by 2, where n is the last number of base, and m is the number of horizontal line, So in the first figure, the base is 1, 2, and the number of horizontal line is 1 and 2. So if we use this formula, n is equal to 2 and m is equal to 2. N is 2 plus 1 divided by 2, which is equal 2 multiplied by 2 equal to 4. Multiply 2 plus 3 equal to 2 plus 1 equal to 3 divided by 2. 4 multiplied by 3 equal to 12 divided by 2, which is equal to 6. So in the figure number 1, there are 6 triangles, and if we count it, this is the first triangle. If we count it, this is the second triangle. This will be the third triangle, and this is the fourth triangle. This will be the fifth triangle, and this will be the sixth triangle. So if we count also, we get we get the result to be 6 triangles. So now we will count the number of triangles for the figure number 2. For the figure number 2, we have to count the number of base. Number of base is 1, 2, 3, 4, and the number of horizontal line 1, 2, and 3. So n equal to 4 multiplied by m equal to 3. This is our formula. N equal to 4 plus 1 divided by 2. 4 multiplied by 3 equal to 12. 5 plus 1 equal to 4 plus 1 equal to 5 divided by 2. 12 multiplied by 5 equal to 60 divided by 2, which is equal to 30. So in this figure number 2, we have 30 numbers of triangle. And now we will try to calculate the number or find the number of triangles in this figure number 3. So here also we have to do the same thing. Count the base 1, 2, 3, 4, 5, and count the number of horizontal 1, 2, 3. N equal to 5, m equal to 3, 5 plus 1 divided by 2. 5 multiplied by 3, it's 15. 5 plus 1 equal to 6 divided by 2. 15 multiplied by 6, we will get 90 divided by 2 equal to 30. So equal to 45. 90 divided by 2 equal to 45. 45. So in this figure number 3, there are 45 numbers of triangles. In this slide, we have another pattern of figures. Figure number 1, figure number 2, figure number 3. And in figure number 1, we can count the number of triangles formed by this inner triangle. This is 1, 2, 3, and 4. And to find the total number of triangles in this figure number 1, we have to add the big or this outer triangle also. So number of triangle is equal to the number of triangles formed by the inner triangle, this inner triangle, that is 4, and plus we have to add this outer triangle or the bigger triangle. So the bigger triangle is 1 plus 1. So 4 plus 1 equal to 5. So there are 5 triangles in figure number 1. And in figure number 2, number of triangles in figure number 2 is equal to, here what in figure number 2 what we have to do, in figure number 2 we see here that there are 2 inner triangles, and we know one inner triangle form 4 triangles. This is 1, 2, 3, and 4 with this one. So in this figure we have two numbers of inner triangles, and if one inner triangle form 4 number of triangles, so two inner triangles, that is this is number 1 and this is number 2 inner triangles. So 2 inner triangles will form 4 plus 4 equal to 8 triangles, and we have to plus this bigger triangle also. This is bigger triangle, that is 1. This 4 is formed by this inner triangle, and this another 4 is formed by this inner triangle, and 1 is formed by the bigger triangle. So 4 plus 1 equal to 9. So in figure number 2 we have 9 numbers of triangles. Now come to the figure number 3. The number of triangles in figure number 3. Here we can see in this figure number 3, we have to count how many inner triangles are there. So this is 1, 2 and 3. There are 3 inner triangles. So we know one inner triangles form 4 triangles. So if 3 inner triangles, so it will form 12 triangles. So let's just say like this one inner triangle form 4 and this one inner triangle form 4 triangles and this third inner triangles form another 4 triangles. Now and the last we have to add with this bigger triangle. So the plus 1. So the number of triangles in this figure number 3 we have 4 plus 4 8, 8 plus 4 equal 12, 12 plus 1 equal to 13. So in figure number 3 we have 13 number of triangles. The number of triangle in this figure, first we have to count the number of inner triangles here. 1, 2, 3 and 4. And one inner triangle form 4 number of triangles. So 4 plus 4 plus 4 plus 4, since there are 4 number of inner triangles and plus this bigger triangle plus 1 equal to 4 plus 4 8, 8 plus 4 8 plus 4 12, 12 plus 4 16, 16 plus 1 17, 17. So we find, if we try to find the number of triangles in this way, suppose the number of in exam, if the figure came and the number of inner triangles came like 5 6 7 number of inner triangles, so it will be bit difficult for us to find the total number of triangles. So for that we have to use a formula. The formula is 4n plus 1, where n is the number of inner triangle embedded inside this outer triangle. So let's try to solve this figure by using this formula. So the number of inner triangle is 1 2 3 4. So 4 multiplied by 4 plus 1 equal to 4 multiplied by 4 equal to 16, 16 plus 1 17. So we find it came to be exact the same 17. Now the number of triangle in this figure, in this pattern of triangles, so in this pattern of triangle we can still use our formula, that is 4n plus 1, 4n plus 1, we can still use this formula but with little bit of modification. So n here is the number of inner triangles 1 2. So 4 multiplied by 2 plus 1, and the modification here is that we have to count this triangle 1 2 3 4 5 6 plus 6 equal to 4 into 2 equal to 8, 8 plus 1 9, 9 plus 6 equal to 15. So the total number of triangles in this figure is 15 triangles. And this is another pattern of figures where we have to find the number of triangles. So number of triangle is equal. Here we have to use another formula. The formula is n multiplied by n plus 2 multiplied by twice n plus 1 divided by 8. This is the formula for counting the number of triangles in this type of pattern. And here the number of the n is equal to number of unit triangle that is present or at the side of the bigger triangle. So here the subunit of triangle here is like this 1 1 1 2 3, and the exemption of this formula is that we can use this formula only if the unit of triangle formed by all the sides of bigger triangle is same. That means the number of triangle formed by this side also 3 1 2 3, and formed by this side also 3, that is 1 2 3, and the triangle formed by this side also 3, 1, 2, 3, or same, maybe 4, 5, 6, but it should be the same. So let us count the number of triangles here. N is equal to number of subunit of triangle. So n here is 3 multiply n 3 plus 2 multiply by 2 multiply by 3 plus 1 divided by 8. So 3 multiply by 3 plus 2 equal to 5 multiply by 2 multiply by 3 equal to 6. 6 plus 1 is 7 divided by 8. So if we multiply 3 multiply by 5, we will get 15. 15 multiply by 7, we will get 105 divided by 8, which is equal to 13.12. Here we find that there is decimal in this case, so we have to take the whole number here. So the total number of triangles in this case is 13 triangles. Or we can also use another tricks here of counting the number of triangles. If we cannot use this formula, what we have to do, we have another trick of counting the number of triangles here. So the trick is, first we have to count the number of triangles formed by the sides of this bigger triangle. So the number of triangles here 1, 2, 3. So we will write here 1, 2 and 3. So for 1 will corresponds 1, and 1 we will plus it, plus with 2 we will get 3, and 3 we will plus with 3 we will get 6. And after this we have to plus all this number, 1 plus 3 plus 6, we will get 1 plus 3, 4, 4 plus 6 equal to 10. And now what we have to do, this trick is a little bit complicated actually. What we have to do now, we have to plus it again. So 10 we will leave here, we have to plus the alternate numbers. So 10 we will leave 6, so we will plus it with 3. So if we plus 10 plus 3, we will get 13. So the total number of triangles in this figure is 13 triangles. This is another example of the same pattern where we can use the formula of n plus 2 twice n plus 1 divided by 8. So here we have to count the number of triangles or the subunit of triangle formed by each side of the bigger triangle. 1, 2, 3, 1, 2, 3, 4. And if we count this side also 1, 2, 3, 4. And if we count this side also 1, 2, 3, 4. So n will be 4. 4 plus 2. 2 multiplied by 4 plus 1 divided by 8 is equal to 4 multiplied by 6 multiplied by 9 divided by 8. 4 multiplied by 6 equal to 24. 24 multiplied by 9 equal to 216 divided by 8, which is equal to 27. So the number of triangle in this figure is 27 if we use the formula. And if we use the another formula for calculating, we'll see. Here the number of subunit of triangle is 4, so we have to write here 1, 2, 3, 4. 1 will correspond to 1, 1, then plus 2 equal to 3, 3 plus 3 equal to 6, 6 plus 4 equal to 10. And after this we have to plus this number, 1 plus 3 plus 6 plus 10. 1 plus 3, 4, 4 plus 6, 10. 10 plus 10 equal to 20. Now after getting this 20, now we have to again to plus the alternate numbers. So 10 we will leave, will come to 6, and 3 we will leave, will come to number 1. So 20 plus 6 equal 26. 26 plus 1 equal to 27. Therefore, the number of triangle in this figure is 27. Now in this slide we have 3 figures, 1, 2, 3, and in exams they might give this type of figures where the square, the figure is of a square and of 2 diagonals which form the triangles. So they will ask how many triangles are there in this figure. So here we have to in this type of pattern we have to count 1, 2, 3, 4, and then the formula will be 4 multiplied by 2 equal to 8. So the formula is whatever the number we get, we will multiply by 2. Then we will get the total number of triangles in this figure, which is formed by a square and the diagonals. So in the figure number 1, we have 8 number of triangles. So in figure number 2, let's see, we will count 1, 2, 3, 4, 5, 6, 7, 8. So there are 8. So 8 multiplied by 2 equal to 16. So the total number of triangles in figure number 2 is 16. And the figure number 3, we have 2 squares. First is the outer square, and the second square is this inner square. So first what we have to do here also it's almost the same, but we have to first we have to count the outer one. 1, 2, 3, 4, 5, 6, 7, 8. So 8 multiplied by 2 equal to 16. And now we'll count the inner square. 1, 2, 3, 4, 5, 6, 7, 8. So 8 multiplied by 2 equal to 16. So now we have to plus this 16 and 16, we will get 32. So the total number of triangles in this figure number 3 is 32. Here is another pattern in which 2 squares combine together. So they will ask the number of triangles here. So how to find the number of triangles in this pattern? So we will count 1, 2, 3, 4. 4 multiplied by 2 equal to 8. Here also 1, 2, 3, 4. 4 multiplied by 2 equal to 8. Here we see there are 2 squares combined at this junction. So we have to see how many points they combine. So here we see there are 2 points in which they combine. This is 1 point and this is another point. So there are 2 points, so we have to add 2 here. So 8 plus 8 equals 16. 16 plus 2 equal to 18. So in this figure there are 18 numbers of triangles. This is another example. This is of same pattern formed by square, but of 3 squares. So how to find the number of triangles here? So we have to count 1, 2, 3, 4. 4 multiplied by 2 equal to 8. Here also 1, 2, 3, 4. 4 multiplied by 2 equal to 8. 1, 2, 3, 4. 4 multiplied by 2 equal to 8. So now we have to find how many points does this 3 squares combine. So this is 1 point, 2, 3, 4. So there are 4 points, so we have to plus 4 here. 8 plus 8, 16, 16 plus 8, 24, 24 plus 8, 28. So there are 28 triangles in this figure.